Hi, everyone. I had a participant ask me about how I draw uh, figures and diagrams that go on my curriculum materials. And so, what I wanted to do is I wanted to call y'all's attention to this zip file that's attached to this module. And it can also be found in my shared Google Drive under Tools and Templates. It's called Tools in PowerPoint form. So I just want to go over them really quickly with you because you might find them useful for whatever, and kind of an answer to this participant's question about how I make my own figures. So the one called 1 centimeter marks and the other one called 2 centimeter marks. These are literally things you just send to the copy machine. And when they come out of the copy machine on regular paper, both the gray and the white stripes are 1 centimeters wide or 2 centimeters wide. And I use that for video analysis, right? An example would be the students take a video with their phone of a cart crashing into another cart, like the Pasco carts on the Pasco track, and then in the video, they take the video from directly overhead, but underneath the track and sticking out would be sheets like this, so that when they go back later, they can go frame by frame and say, okay, well, this is how far this was, or something like that, right? Okay, so that's what those are for. Okay. Let's see. This is a protractor with single degree marks. And the idea is that if you print this out and then put it into a 3-hole punch, the center hole of the 3-hole punch will be right in the center of the circle. And I use this for like pendulum experiments and things where I 3-hole punch them right in the center so that they balance, right? So that they're balanced when you stick. And then I stick a little a little bolt or something onto a stand, and I just put the hole that I 3-hole punch the center hole onto the bolt, and then you can attach the pendulum to it, but you've got a little protractor with 0 degrees pointing straight down. The other protractor I have is only by tens of degrees. So same goes, right? Let's see. This is called rotating surface measurement. So what I do is I have surfaces that can go onto something that can rotate. Frankly, they're little planks of wood that go on a record player. And then the student, like, they have the record player, goes around, they put the coin on it or whatever. So I've collected some record players over time. The idea is that I glue this to the top of the little plank and then the plank has a little hole in it that goes right over the center of the record player. And then basically this is a convenient way that students can measure distances from the center of the circle. And of course, I haven't been moving, so the lights in my classroom turn off because, heaven forbid, we're in an energy crisis like it's the Carter era here in our district, right? Okay. I'm in the state of Texas. We produce energy. This is what you probably really wanted to see was these files. One is a set of different graph grids. And the reason why I have white on black is for if you create PowerPoints to show your students, including log and semi-log plots, get this and get it good. Don't put black text on white background if you're going to show something on a screen. This isn't a book. It's a screen. White text on black. If you use my lesson slides, you see that. It is so much easier on the eyes. If your students have a visual like impairment, then that is much better for the visually. So the non-visually impaired students can read it better. The visually impaired students, so get out of this habit. I know PowerPoint defaults to black text on white background. No, white text, black background, or colorful bright text on a black background, or a very dark blue or green or something like that. So that's these. These are the exact same ones, except they are on black on white because then you can print them. That's the only time we do black on white is when we're expecting to send it to a printer. You can see different polar graphs here. And then you can see the polar in the background and the Cartesian in the foreground and the polar on Cartesian. You get the idea. Who knows? And then this is just a blank grid. And then this is for free body diagrams right here. Okay, so the curves and symbols are pre-made curve templates. They are really close to exactly precise. Okay, I mean they're within about 1% at any point you look. So these are literal parabolas. They're not kind of parabolas. They're exact parabolas. I believe this is y equals x cubed minus 3x. These are different hyperbolas in case you teach like algebra or you want to show that. You're welcome to share this with your math teachers. That's fine with me. Share this video with them too. It's available on YouTube. Let's see. Inverse curves. Yeah, so hyperbola. So this is 1 over x, or y equals c over x. This is 1 over x squared, different versions of that. This is here because this is the axis of that. So don't just grab this, grab all of it, will you? Does that make sense? And then same goes here. Like that is supposed to go with these axes to make it exactly precise. And if you don't believe me, take any of these you want and put them on one of these, on one of these, and tell me that they are not like going through the exact points. Like they are very precise. These are sines and cosines, different pieces of them. Tangent with its asymptotes, secant and cosecant, exponent and log with their asymptotes shown, a Gaussian distribution with the whatever you call it's not quartiles, a standard deviation shown, Maxwell-Boltzmann distributions for speed and for kinetic energy, in case you teach thermodynamics, circuit symbols, field symbols, up, down, left, right, in and out of the page, symbols for charge, just kind of miscellaneous other things like a car seen from above or a really thick spring or different lenses or whatever, different text boxes. These are my square conservation momentum squares that I invented. Apparently they're showing up in textbooks now. The new Akina textbook I hear has these in it, and I'm trying to get a hold of a sample copy, not because I want to make any trouble for Dr. Akina, but because I want to phone her up and say, hey, as far as I'm concerned, I'm the originator of these representations. I'd be interested in helping you, make it look really good in your textbook, because I've seen people try to copy them and they're not being used exactly the way that I think is best. And I'm the guy who invented them. Okay. Longer conservation momentum diagrams, energy bar charts with positive and negative. I want to make the squares, but for continuity in fluids, right? So when fluids comes over to P1, I'm going to be using the squares again. I want to come up with a representation for the junction rule where you have to shade in the arrow and the boxes representing the current, showing the current in equals the current out. I haven't really developed that idea just yet. This is this representation that you see a lot in modeling where the student needs to show the potential going up and then going down and down or through the resistors. Not sure why the letter I is here. I'm not sure what I was thinking for that representation, honestly. So I'll have to come back and think about it. Bernoulli bar charts, the rectangles, but for Snell's law. The rectangles, but for n sine theta equals n sine theta, kind of like mv equals mv. But this area down here is blanked out because you cannot make a rectangle that has an n that's less than 1. Right. So again, that's I haven't taught AP Physics 2 in a long time, so I have not developed this idea quite yet. Please note on the bottom that is actually the number of degrees. So I basically took the inverse sine of each of these numbers, or I took the sine of each of these numbers and placed their degrees on their sines. Right. You see how that works? N can't be less than 1. I think I said that. Those are different free body diagrams that you can use as templates. Right. So let's say for the heck of it that I'm going to open up a new PowerPoint and I'm going to make a diagram like the kind that you've seen in my shit, right? Okay. So I am going to randomly select a number between 1 and 15. I got 2. I believe that is forces and Newton's laws. So I don't want any of this stuff here. And so what can I do for force and Newton's laws? Where's my draw tools here, right? Okay. So I want to insert like boxes and stuff. I use an old version of PowerPoint. So if it looks like I'm struggling, it's because this is the PowerPoint I use is from like 1997. I'm not even freaking lying about that. Okay. So I don't know. Actually, you know what? I'm going to go 1 unit before. I'm going to do unit 1, and it's going to be like a projectile motion, just so you can see me do this, where I take like, okay, here's this. I'm going to copy. I'm going to paste. Right. You see that? And then this is going to be a building. And then this is going to be like the projectile going off the building. And then I'm going to insert like another shape, which is going to be a straight line. I'm going to make the straight line right here, whatever kind of thing. Okay, all good. And then maybe you can draw a stick figure person, or you can draw like a ball. Heaven forbid that the draw tools stay exactly there rather than I keep going back over and over again. You see, that's why I don't use the new PowerPoint. I hate Microsoft tools. They get worse and worse every year. Okay, so there's the ball and there's the building, everything. So how do you put it in your documents? I'm going to select the whole thing. I'm going to copy it. And I'm going to copy it into Microsoft Paint and then paste it. You see, there it is. In fact, I actually make this a little bit smaller. And then I will copy it now. And then that is what will go into the Word document. So that's how I make the figures that I make. Is first of all, I use an old version of PowerPoint, which is much easier for me to use and much more reliable. All right, so here we go. Come on, is it going to be so good? So now this is something that's much easier to do. If you copy, let me show you what happens if you copy from PowerPoint directly into Word. If you copy from PowerPoint directly into Word, then now it's possible to like move everything apart. And I don't want that in the middle of my Word document. Come on. So let's get rid of this stuff. And also what happens when I push, okay, but then now the text is behind it, right? It's screwy, okay? Here, you can't, the text is in front of it. Oh, the text is behind it. You can't get text behind it, right? Does that make sense? Now, anytime I make diagrams, you better believe I save the PowerPoint where I made the diagram in, right? So I have PowerPoints that are like Unit 1 diagrams, Unit 2 diagrams, those kind of things, diagrams for the questions I write and that kind of thing. So if you do work, don't ever throw it away. And you want to know why? Because you may need this again. You may be like, oh, I need another one. Only this time the building is smaller, right? Or whatever, So then for whatever reason, the building is smaller. So you don't have to redo all that work. Does that make sense? Okay, so that's it. That's how I make diagrams. Where does he get all those wonderful toys, right? From Batman. Where does he make all those wonderful diagrams? Now you know why, and I'm giving you these. Please don't be afraid to show this to your math teachers. They probably love some of these symbols and graphs. If you do, let them know who I am. Show them my website, Phine-physics.com. I do seminars in the summer for physics teachers, which you'll hear about because you're on my mailing list. But I also do seminars in the summer for math teachers where I show them how they can do hands-on stuff like physics, but just without the physics, only the math. For example, using a bucket with water in it and a rubber band to learn about line. So that'd be good for Algebra 1. Or a bottle with water in it with a hole in it and it pees out, and that the students can learn about parabola from that, right? So I have over 40 activities that go from 7th grade all the way through BC Calculus and Statistics, AP. I have like a bunch of different games. I have performance-based assessments, all for math, all to make math more relevant and more interesting. And I'm just trying to get a math following the same as I have a physics following. And that benefits you too. When your math teachers teach math better, that makes your life as a physics teacher easier. So find Phine-physics.com. You can find me there. You can contact me, reach out to me. Your math teachers can also reach out to me if they want this, or if they want to be a part of one of my seminars, then I'd love to have them. I'd love to show them some things that they can do that's cool. All right. Thanks for watching.